going to be simplifying square roots. We're going to just work through some examples. So hopefully we can get that, because it should be, again, a review, simplifying a square root. We're going to start with the square root of 18. Actually, we're going to start even simpler than that. We're going to start with the square root of 25. Now, the square root of 25, you should know right off the top of your head. You're going, it's 5. Duh. Of course it's 5. Mrs. Zoltan, why? What's going on? Well, the reason it's 5, that's what we want to talk about. If I were to break down 25, I would get 5 times 5. This pair of 5s is what gives me the whole solution of 5. So now when I look at the square root of 18, and I break it down, and the square root of 18, I get either 9 and 2 or 3 and 6. It makes absolutely no difference. Let's go 3, 6. Therefore, 6 is 3 and 2. When we're looking at breaking down square roots, we always look for pairs, hence square. Square means 2. So you need 2 roots. And in this case, the roots are 3. You need 2 roots to make 1. And if you don't have 2, you stay left inside. Now, one thing I kind of use with it is, if you're a pair, you go out, and if you're single, you stay home. So the pairs went out, and the single stayed home. All right. If I throw a negative in front of a radical, and we'll talk about in the next day or two what happens when a negative is underneath. But if I throw a negative in front of a radical, that negative just stays so that my solution is negative. All right. If I have a fraction, so let's look at the square root of 49 over 81. That is like saying the square root of 49 and the square root of 81. I can split that radical apart. We should know the square root of 49, and we should know the square root of 81, so that we get 7/9 as a whole number. No leftovers. They all had pairs. Okay, so let's go to multiply. When you multiply, you do insides together and outsides together. So the square root of 8 times the square root of 3. The insides are 8 and 3. I get 24. At this point, I always need to reduce. Anything we ever do in math, we always reduce down to the simplest form. So 24, well, it's 8 and 3, 6 and 4, it's 2 and 12. It doesn't really matter how you want to break this down. If we break it down to where it came from, that's fine. 8 and 3, well, that's 2 and 4, which is 2 and 2. I have one pair of 2's. That's going to come out. But I have a leftover 2 and a leftover 3. They are left over as multiplication, because 24, these are all factors of 24, so it's all multiplied. So 2 and 3 left over gives me a 6. All right, what about 1/2 times 1/8? Well, we should know that when we multiply fractions, we multiply top with top, bottom with bottom. So this gives me 1/16. And what we just got from above is that we can separate that. the square root of 1 is 1. The square root of 16, we should know as 4. So that solution is 1/4. Dividing. Ooh, that color doesn't show very well. There we go. When we are dividing, you cannot have radicals in the denominator. If they are the denominator, we do a process that's called rationalizing the denominator. So here I have 5 over root 2. All right, can't have the radical in denominator. Just got done saying it. So the mathematical process that we do is called rationalizing the denominator. What that really means is get the radical out of the denominator. The way we get a radical out of the denominator is we make it a whole number. The only way radical 2 can become a whole number is if I multiply it by its same thing. Because the square root of 2 times the square root of 2 is a square root of 4. And the square root of 4 is 2. So the only way we get rid of a radical in the denominator is to multiply by it. But just like anything we do with fractions, if you do it to the bottom, you got to do it to the top. So 5 times root 2 is 5 root 2. So we get 5 root 2 over 2. Let's try that again. If I have 3 root 2 over square root of 5. All right, we don't care about the numerator, we only care about the denominator when we're dividing with radicals. We can't have a radical in the denominator, so we've got to get rid of the square root of 5. We get rid of the square root of 5 by multiplying by a square root of 5. When I multiply root 5, it gives me the whole number of 5. Now on top, I have 3 root 2 times 5. Well, we just got done up here. Insides go with insides, outsides go with outsides. So here, 3 is outside, 2 and 5 are inside. So only 2 and 5 get multiplied together. 3 root 10. You're done. Okay? And that's going to be the first part that we talk about with simplifying square roots.